Here's our lesson for Chapter 6, Lessons 1 and 2 on discrete and continuous random variables. Please keep in mind this guiding question. What is a random variable and how are discrete random variables different from continuous random variables? Random variable. Discrete would be a fixed set of values, like counting something. Oftentimes these are whole numbers. So for the number of shots made out of 100 for a basketball player, the number of students in a class. Continuous variables take on values in an interval, so measuring lengths, weights. You can have a decimal, like you can be 180.245 pounds. So continuous takes on all values in an interval. Discrete variables, just fixed sets. So a probability distribution. What that is, we've looked at this a lot in the last chapter, but now we're giving it a name, and we're talking about what happens when you apply certain functions to a distribution, a probability distribution. So it gives all possible values of a random variable and their probabilities. So for rolling a six-sided die, a 1, 2, 3, 4, 5, 6 are their possibilities. They all have an equal probability of 1/6 on a legitimate die of coming up. So 1/6 being assigned to each of those. Similar definition is in Chapter 1 for distribution, but here we're looking at a value and then how likely it takes that on that value. And we can estimate that by doing a large number of trials and seeing what proportion of the time that value comes up. So some of this is a little bit of review here. So shape, center, and expected value, and then spread. So shape, center, expected value, and spread. Shape is identifying the graph of the histogram of probability distribution with the height of each bar representing the probability. So we're looking, just graphing the histogram, and we're looking at the overall shape. Is it skewed left? Is it skewed right? Is it a bell curve? Is it unimodal? Is it uniform? Does it have, where are the peaks? The center, we usually identify it by the mean here. What we call the mean is the expected value. The expected value is what we'd expect to get over a large number of outcomes. We're going to talk about in a little bit about how we calculate that. It's basically the average, but the weighted average. So it's like you take the value of each possible outcome and multiply it by the probability of that outcome, and then you add those all up for the distribution. Think about when we might use the median, similar to other times that we've talked about. So expected value should be what we'd get if we repeated the process infinitely many times. So if we just went on to the super long run of infinity. The spread is usually identified by the standard deviation of the random variable, which describes how the values differ from the expected value on average. Density curves, including a normal distribution, that's the distribution of a continuous random variable. The probability is determined by finding the area under the density curve. So just like we looked at the normal distribution before and we said what percent of the normal curve was at z equals -1 or less, we are looking at the area under the curve. Same thing here. Here we have an example. Probability that x is greater than or equal to 1 is 7/8. Means that if we were to repeatedly flip a coin here, let's say the event is flipping 3 coins and record the number of heads. In the long run, about 87.5% of the time we'll get one or more heads. We'd rarely not get any heads. So we have even though discrete variables have a fixed set of values, set of possible values can be infinite. So like number of rolls of a fair die needed to get a 6, there's no upper limit. Just by chance it may take a really long time, a lot of rolls. 2 number lines, one indicating possible shoe sizes is 5 through 15, and one indicating the length of subject's feet 5 to 15 inches. Right now, pause, which one is discrete and which one's continuous? Shoe sizes or the length of the subject's feet? Well, it turns out shoe sizes go 5, 5.5, 6 for the most part, so they're discrete. The length of somebody's feet, that would be continuous because you could be 5.01 inches, 5.02, 5.01345 inches. It takes on an interval of values. So here's what a probability distribution would look like. This would be a discrete value, right? So we have our values here, the first value, second value, third value, and then the probability of this first value, the probability of the second value, the probability of this third value. Every probability is a number between 0 and 1. When you add up all these probabilities, they should equal 1, or 100% of the time, all the possible outcomes. We can graph on our calculators by creating two lists. We can create L1 would be the value, L2 would be the probabilities of the values, and then we can graph the histogram with the probabilities being the frequency. So at the beginning of the year, I told you not to worry about the frequency. We'll use that later on in the year, and here we are. The probabilities would be the frequency, meaning how often we'd expect that certain value to appear, or the frequency with which we'd expect to see each value occur. We could do the expected value by adding up, multiplying the first outcome times its probability, adding it to multiplying the second outcome by its probability, and so on. That's the expected value. Okay, we could find the variance of probability distribution by subtracting each value from the expected value. So we'd find the expected value first, like up here. Then we would take each individual value and subtract it from that. So how far is it from the expected value, or the average, the mean? And then square that, remember, because we're just looking for distance. We don't care if it's below or above. We want to see how far things are from the mean. And you multiply it by its probability, because that would give us, that would weight it to show how often that appears. And you continue like that with all the values. Now, if you took a square root of all that, that would be the standard deviation. Now, luckily, you can do this on your calculator as well for help with those. Continuous random variables and their probability distribution. Since a continuous random variable can take on all values in an interval, there's an infinite amount of values. Just like saying there's an infinite amount of numbers between 0 and 1. Because you can keep extending to more and more decimal places to the right, there's an infinite numbers. So there's an infinite possible of values between 0.3 and 0.7, because there's so many numbers you could extend it to. To find the probability of an interval, we'd look at the density curve and look at the area. So you'd find 0.3 and 0.7 on the density curve. You draw a line from the x-axis up to the curve from both of those. And then the area in between those, but under the curve, would represent the probability. So it's the area between those two values under the curve. So that's the basic intro to probability distributions. We're going to look at transforming and combining random variables. What happens when we transform them by multiplying, dividing, adding, or subtracting, or also combining two sets. So look at this guiding question and think about this. How does combining the two sets of data by adding, subtracting, multiplying, dividing change the shape, center, and spread? And this will be the free response to focus on for the answer below. So types of questions we could answer with these are: is there a significant difference in the mean salaries for men and women in a certain industry? Do patients taking a new drug have a higher survival rate than those taking currently used drug? There's also all types of probabilities we can determine to find the probability of the number of times it'll take till one success in a certain chance process. So let's look at linear transformations first. So adding and subtracting a constant, just like before, so this should be a review, adds a to the measure of centers and location, meaning the mean, the median, the quartiles, and percentiles, because you're adding a to every number. In the same way it would subtract if it was a negative number. It's like adding a negative. It doesn't change the shape, doesn't change measures of spread like range, IQR, and standard deviation. So this should be review, just like before. Multiplying and dividing multiplies each or divides each observation by a constant b. Multiplies or divides measures of spread, range, IQR, and standard deviation by that absolute value of b, but won't change the shape. You can think about it, multiplying by a number bigger than 1 would stretch out the distribution. Multiplying by a number smaller than 1, which would be the same as dividing by a number bigger than 1, would shrink and bring in the sides, would shrink the spread. Okay, effects on mean and standard deviation. So if we looked at adding a constant a, multiplying by a constant b, the probability distribution of y has the same shape as the probability distribution of x, because adding and multiplying by a number doesn't change the shape. The mean, you would add the constant a and you'd multiply by the number that you're multiplying by. So this is just doing what we were just talked about, but applying both the adding a constant and multiplying. The standard deviation, remember, measures of spread aren't changed by a. Since all the numbers receive or added that number, it's like just shifting it left or right. So adding or subtracting a number doesn't change the spread. However, multiplying by a number will. So multiplying by a number bigger than 1 would stretch it out, and the standard deviation would be multiplied by that. Multiplying by a number smaller than 1 would shrink it, or dividing by a number bigger than 1 would shrink it. The mean of the sum of random variables. So if we take the expected value of t, which the mean of t would be the mean of the x plus the mean of the y. So this means if we have 2 data sets, 2 random variables, like the sum of a 6-sided roll and 8-sided roll, and we're adding those 2 up for some reason for a game, then we would take the average of the 6-sided roll, x here, and add that to the average of the 8-sided roll. So in general, the mean of the sum of several random variables is the sum of their means. So the mean of the sum, meaning we added the variables together, it's the same as adding all the individual means up. And always remember, more variables means more variability. This is key. Doesn't matter if we're adding or subtracting. We're always going to have more variability if we add 2 variables or subtract them. So here we have an example about the probability of the number of passengers expected on a Jeep tour. So this is maybe from data they've collected over the years or over the last year. And they want to know how likely it is they're going to have a full tour of 6, how likely it is they're only going to have 3. To find the expected value, add up 2 times 0.15, plus 3 times 0.25, plus 4 times 0.35, plus 5 times 0.2, plus 6 times 0.05. So we get 3.75. That means on average we'd expect 3 3/4 passengers, or about 4 passengers. It's a discrete variable, right? So 3.75 isn't the best answer to go with. We can't have 3/4 of a person. For the variance, we'd use that average, the expected value, 2 minus 3.75 squared times the probability of 0.15. 3 minus the expected value squared times 0.25, and so on. That's the variance there, and then we take the square root of that to find the standard deviation. Okay, independent random variables, this is just the same as we went over in Chapter 5, that any event involving x doesn't have any effect on the probability of y occurring. So they're independent random variables. So we'll continue to be a big part of the curriculum, so make sure if you're still having trouble with independence, you talk to me. Remember, it's the idea that the probability of an event is the same regardless of whether a second event has occurred. That's the definition for the mathematical definition we gave it. The variance of the sum of independent random variables, for any 2 independent variables, variances add up. So if you're given standard deviation, you need to square it to get the variance. Add up the variance of each data set and get the variance of the total, the combination. So if we add 2 random variables, x and y, like I said, a 6-sided die and an 8-sided die, you need to first you need to square their standard deviations to get variance, add them up. That would be the variance of the sum of those 2 independent random variables, and then we would take the square root of that if we wanted to find the standard deviation. So in general, the variance of the sum of several independent random variables is the sum of their variances. Just like the Pythagorean theorem only applies to right triangles, this only applies to independent random variables. So it only works for independent random variables, otherwise variances don't necessarily add. The mean of difference of random variables, we subtract the means. So if I'm adding 2 data sets, x and y, I add them. If I'm subtracting, I subtract their means. So the mean of the difference of several random variables is the difference of their means. That just means what we just talked about there. That's what this sentence is trying to say. The variance of different random variables. Variance of difference. For any 2 independent random variables, if we subtract random variable y from x, then the variance of d is the sum of the variances. Now that's very important. It's not the difference. For variance, more variables, more variance. So pay close attention right here. The variance, the total variance when we subtract these 2, is the variance of x plus variance of y, even though we subtracted. More variables, more variance. There's more data, it's more likely to vary from the mean. The sum or difference of independent normal random variables follows a normal distribution. So if we're adding or subtracting normal random variables, it's a normal distribution, because remember, shape isn't changed. Okay, so we're trying here in the multiple choice. So pause right now, look over the outlines in the book, or the summaries in the book for 6.1 and 6.2. So here in this multiple choice, we're trying to determine if there's a discrepancy between the mean salaries of men and women in California. So to do so, we subtract the women's salaries from the men's. What happens to the expected value of the difference and the variance of the difference of our new data set results? So here are the different options. Please predict based on what you saw in this video and what you see in the outline of what you'd expect the expected value, or the mean of the, remember we're subtracting men's salaries minus women's salaries, and what the variance would do.